Now to the implementation backing HUICA. Here the Gemstone technology stack is the essential point. Around 7,000 lines of code and about 50 individual libraries and frameworks were required to integrate all pre-existing solutions and extend them to be able to drive HUICA in practice. There's a lot of stuff and a lot of code, but the point is it's available as an open source project under gemstonejs.com, and so you no longer have to take care about this yourself. Instead, when implementing a particular application, HUICA is as simple as the usual hello world in the web, because everything is encapsulated inside the Gemstone technology stack. So what is actually required is a little bit of an NPM specification on the left top for the dependencies, a little bit of Gemstone specification on the bottom left, plus a little bit of JavaScript code to fire up the framework on the top right, a little bit of an HTML snippet here on the right in the middle, plus a few commands to install dependencies, build the application and finally start the application, and voila, you have the usual hello world available, even if a lot of things happen in the background. So the point is, even HUICA is a comprehensive architecture for user interfaces. Thanks to the Gemstone technology stack backing it, you no longer have to take care about all the details, and as you see it, a hello world and even a whole application is as simple as with other web technologies. On the experience side, a lot of things were implemented during my doctorate inside the industry. Here, over a dozen applications were created. Classical business information systems, mobile applications, even technical applications, they all are backed by HUICA, even if their particular user interfaces are completely different. So in total, these were 14 different applications created in the industry over the last 6 or 7 years, and they look completely different, but they are all backed by HUICA. You see here a few of the screenshots of those applications. This ranges from technical applications, mobile applications, up to the classical business applications, even on the right side, gaming applications or portals, and on the top, tablet applications. Then there are also classical business information systems driven by lots of forms. You see it here on the left, which is more or less like Excel. There are also complex forms on the top right, and even up to graphical diagram-driven applications. And it can be even completely different things like small applications on the web, TV and video streaming application, over few portals, etc. All this is backed by exactly the same architecture, HUICA. HUICA especially allows us to really scale in those applications. On the left you see a screenshot of CAMPS. This is a demo application showing more or less the management of a campus at a university, and the point of this is, you see it on the right, the dialogues, lots of dialogues, but even if a plus button is pressed on the left top of this screenshot to open a new tab, the whole user interface is instantiated multiple times. This means that not just this screenshot now correlates to, on the left, correlates to the component tree on the right. Once we press on the plus button and get a new tab, the entire UI is duplicated, and this really scales very well thanks to the underlying HUICA. Now to the evaluation, because in the dissertation, as shown initially, I had a requirements suite, and it gave my best to, with HUICA on the conceptual side, to really solve all those or resolve all those requirements. Nevertheless, not all things could be perfectly addressed by HUICA on the conceptual side. The reason is more or less that over time I learned myself that a few of those requirements are not just solvable on the conceptual side, but also need the implementation side. So yes, in total, thanks to the Gemstone stack, all stated requirements can be perfectly or more or less perfectly fit, while when we are fair and just look at HUICA as the conceptual side, there are a few things where HUICA is just good or very good, but not perfect. This is the result of the academic evaluation from my perspective as an upstream author. There's also a developer evaluation done by co-workers and people worked with HUICA. It's more or less similar. A few things got evaluated a little bit not such good, and other things are a little bit of difference, but it's very harmless, the difference. So more or less I can state, yes, the initial requirements I gave to myself at the start of the doctorate were fulfilled, both from an upstream author and a downstream developer perspective. The interesting points in HUICA are also that there's other practical feedback from the downstream developers, things like whether is now an imperative versus a declarative data binding more intuitive and useful. There the declarative data binding clearly won. Even if an imperative one is more or less used initially, but later we switched even in our applications to a declarative data binding. There's also the issue of a reduced versus a full-blown MVCCT triads. This is also a nice discussion happening all the time. Should one also use for each dialog a triad, so model, view and controller, or are there reduced patterns where, for instance, just a widget consisting of just a model and a view, and another intermediate dialog, perhaps just of a controller, is the more reasonable one. Here the reduced variant one more or less. There's other interesting things like explicit versus automatic resource allocation spooling. Here the automated variant were preferred. A code first versus a contract first approach was evaluated during my doctorate. Here also the pragmatic code first approach was chosen. And finally there was this distinction of a natural versus a traditional computer science visualization of the component tree. You know, in computer science, trees usually have the root at the top and the leaves at the bottom. In HUICA, as seen before, it actually, we prefer the natural order where the root is at the bottom and the leaves are at the top. Finally, to the conclusion. The reached goals and the lessons learned. Well, on one side, the requirements suite was mastered and fulfilled. And from my perspective, yes, the HUICA is really a proven component-oriented software architecture, proven because even 14 applications were created thanks to HUICA and they work pretty well. So one can really say, yes, HUICA worked perfectly, especially thanks to the companion technology stack Gemstone.js. A few lessons learned also came out. The first point is that web technologies is really a cruel world because it has a very rapid evolution. This is great because a lot of new things occur all the time, but it's really a moving target, and this rapid evolution can make a lot of trouble, especially if one has to integrate all libraries and frameworks yourself, and if you wouldn't have a technology stack, a pre-integrated stack like Gemstone.js at hand. Then there's this recurring reinventions of the wheel on the web, where lots of libraries and frameworks came out and more or less do the same as the libraries before, just with a little bit of or subtle differences this time. Then there was this component system details, these subtle details. Component.js was really hard to get right because especially the invariants should hold at any time, independent what an application actually does through the API. So independent whether a component is triggered to go upwards or increase the state, or go downwards and decrease the state, the invariants always have to hold to get a consistent UI. And this was very, very complicated because there are really horrible subtle details and special cases. Then there's this feature over scalability on the market. It became clear during the doctorate that more or less all components, and not components, libraries and frameworks on the market prefer to provide lots of cool features. But the scalability aspects that Gemstone and HUICA try to address, to scale with hundreds of dialogues, to get the team really independent working on the dialogues, is something which is more or less neglected on the market as it looks. Then there's this need for a corresponding framework. It became clear that HUICA is a complex architecture, definitely, so it shouldn't be implemented in an application from scratch. Instead, really a corresponding framework like Component.js on the component orientation side plus Gemstone as the whole tool stack is needed. So this integration technology stack, Gemstone, and the underlying component frameworks like Component.js are really needed. And finally, one also lesson learned is that HUICA works perfectly for the current rich client architecture era, but whether it really works for thin client architecture or other aspects is not really clear and was not actually part of the investigation. So it's a perfect match, yes, for the current rich client architecture era. Then a few future prospects. What can be done in the near or in the far future now that HUICA was published as a dissertation? Well, the first point is there are lots of reusable patterns in practice, and I documented the most important ones. Over time, we perhaps see that more patterns exist related to HUICA which can be documented. Also best practices and other things on creative, the act of designing component hierarchies. Things like, what is the best way to really split an UI into a component tree, and other things can be further investigated. Then there's this full business data model synchronization in just a data binding approach. In HUICA, I'm talking just about the data binding where data is transferred back and forth between the front end and the back end. But one of the master's theses I supervised also investigated in a full synchronization of data where the front end more or less no longer knows that there is a backend. It just manipulates its own data model, and this is more or less magically synchronized with the backend. There can be further investigations to better understand this alternative approach. Also, one should actually migrate things like Component.js to perhaps the latest ECMAScript 2018 or now 2019 world order, perhaps with proxy objects and other nice new features which could provide a little bit of nicer APIs, for instance. And finally, there's currently the W3C custom elements and web components, and they are playing more or less on the widget level. And the interesting point where it should be investigated is the interweaving of the HUICA, which more or less plays on the dialog and this way a macro level, with those lower end widget level things. The future prospects, or the far future prospects, are then, as once mentioned, to really do an adoption in other HTML5 single-page application technology stacks. For instance, Angular.js, React.js, and others, to really also perhaps benefit from an approach like HUICA. Perhaps, as mentioned before, also to adopt HUICA for a thin client architecture approach. I've currently no real clue how this really could work, but I could imagine perhaps that the whole states and the whole component tree is actually located on the server side, and then finally just an update, an incremental view mask update process perhaps updates the client in such an approach. Then there could be a modeling approach where dialogues and other things could be really modeled through a domain-specific language or a GUI approach, and perhaps even code structures generated out of this. This was also something I thought about, but it really would make an explosion of HUICA and my dissertation. So this is something for future prospects, but an interesting approach where certainly further master's thesis and other things could invest. And yes, to be fair enough, in my dissertation, I did just not a broad downstream developer evaluation. I just interviewed a few of the persons, and this could be actually done on a more broader scope once more developers are actually working with HUICA and implemented even more applications with HUICA. Finally, thanks very much to my supervisor, Dr. Alexander Knapp at University of Augsburg, and especially also to Bernhard Bauer, my secondary assessor and secondary advisor. Then also thanks to the other assessors, reviewers, my thesis students, and the people who gave me feedback during my doctorate, and especially feedback for the dissertation itself. Thank you, because just because of your feedback, I think HUICA was able to be a successful solution at the end. Thank you very much for listening.